Bum 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 bum.
Tomatoes?
Hello, and welcome to video 4, C++ with blueprints, exposing the collision profile struct name. Long title, really short goal. We have a collision name structure. This thing contains a name. It contains the name of the collision profile we've selected. So like for example, here's my collision name and I'm selecting no collision, but we cannot access that name property. It is hidden. It's set to edit anywhere, but not blueprintable, which means we cannot get it from blueprints, only from C++ code. And we want it. We cannot plug this structure into here, which means our code doesn't work. We want to be able to set the collision profile name really simple from this cool drop-down box instead of typing in my name. So we create a node to get to it. So under my helpers here, I have get profile name. And this simply grabs the profile name, which we can't get to without C++, and makes a blueprint node out of it, which we can plug right in. So now I can run into this nice little box, hit change collision, and it changes to whatever I've got it set to. In that case, no collision. Super simple, except we have to do this. So let me open it up. We're using another blueprint function library. You can put this wherever you want in an existing blueprint function library, or in this case, I made my own just to make it clean. Now looking at this, well, there's not much code in either one because, well, it's pretty simple. We have our includes that we need. We need the collision profile because we are using F collision profile name. So like, for example, if you didn't know what you needed, we have the documentation. So we know in blueprints, we have a collision profile name structure. If we search through here, we find the collision profile name structure with an F in front of it because it's one of the naming conventions of Unreal Engine. You'll notice it has the name, and you'll notice it's part of engine collision profile, which engine collision profile, and that gives us access to our F collision profile. Again, it all comes back to just reading through the documentation, putting the files in the right place so we have access to it, and then copy pasting your code basically. So in this case, you haven't seen this before, but we're actually going to return back an F name from our static function. So we're going to return back a name. We call our function getProfileName, and it's going to take in a profile. Now we're doing this because this one's really simple. We're taking in something and returning something, so we don't need to worry about our outs or our as value or ampersand or any of the other stuff. We just really simple function. We're going to do something in here and return back a value. We look at how it works, and again, really simple. We're passing in an F collision profile name, and the name of it is profile, our variable name, and all we're going to return back is the .name property of our profile. If we look at our code in the engine itself, here's our collision profile name. Here's our name property, which if this said blueprint read only, we would have access to it, but we don't. So all we're doing is saying, hey, give me that name, which I can't do anything with, and let's return that out as the return value from this blueprint pure node. And our category is going to be helpers. And that's it. And you saw how it worked. We now have our get profile name, and it returns it. Now, since we're here, let's say you're iterating over some things and you're making some changes. You want some things to be done differently. You want to make some code changes, but you don't necessarily want to keep recompiling the engine or the module, or you don't want to swap back and forth. The safest way to be working in C++ is to, let's close down our project, close down our solution file. We are going to open up our folder once we can figure out where we put it. And you open up your solution file. So this is the solution file for my project. And then you work in your C++ code, and then you would debug, and you would run your debugger, and that's going to launch the editor, and you work in the editor. And then when you're done, or you need to make some changes to your code, you need to close down your editor, make the changes to your code, and then relaunch the editor. And that can slow down your iteration time, especially if you're used to blueprints, which are really quick and simple. Like, for example, if I came back into here and, oh, no, I don't want that to be helpers. I wanted that to be collision. Wait, I can't build because I'm debugging, but, oh, crap. So then I'd have to stop, which kills my editor that's running, and then rebuild. Now, if you happen to launch them separately, so you have the project running by the project itself, and then you have the solution file running as well. So let's close down the solution file, launch the project file, and then we can open our Visual Studio. It's going to go ahead and allow you to hot reload. So what that does is we have our category collision, right? And if we go back into here and we find where we put our code, we go in here and we do this and we look at our code. Here's our get profile name. Drag off of there again. You'll notice it's still under helpers. We want it to be under collision, but we haven't recompiled our code. Our compile button allows us to hot reload. So like it says, it tries, you know it doesn't say try, it tries to recompile and reload the C++ code for game systems on the fly. Now this is a sore subject for a lot of people. Depending on the code changes you've made, this can fail. And it can fail in ways that you don't expect, which cascades, and then all of a sudden, half an hour later, you're racking your brain on why something doesn't work, and it's related to the fact that you hot reloaded, rather than reloaded the engine completely with the brand new module. So if I compile this, and I look at my output log, and we'll see it's starting to hot reload, and it's going to compile it. It's going to do its best to compile, unload the old module, and load the new module in. And in this case, it didn't seem like it had an issue. If we go into here and we drag this off, you'll now see it's under collision because it does a good job of rebuilding some of these things. But if you changed a core function of the header file, stop your project, build it out in Visual Studio, and then relaunch the project. Relaunch it through here in debugging, or just go ahead and relaunch it through here. Changes to your header are one of the main reasons why you end up with issues with C++. It just can't handle it very well with hot reload, especially if you change the amount of profiles, the amount of properties that go in or out and things like that. Once your header's good to go here, do whatever you want inside of your functions. Feel free to change those. Like for example, return, like for example, I could go in here and I could do, int blah equals blah. Oh, that's minus equals blah. Oh, we need numbers, right? So 10 times 20. Okay, cool. And then I can save this, go back into here, hit compile. Not even worried about it. I've done some changes to the code, but not the actual header itself. 99% of the time, you're not going to run into any issues if you hot reload like this. So feel free to do that. And then as you can see, now I can go back in and check my new node, If you need to do something, you want to make sure it's the latest one, right click and refresh it. So that way it gets the latest one, or just drag it off and redo it again if you're changing things. But if you're just expecting values to change and things like that, you don't even have to do that. So header changes, don't hot reload. Reload the entire editor after you recompile in Visual Studio. Just changing to the source files. Feel free to use hot reload. This is my personal opinion and experience. Everyone feels differently. If you ever think you're going to run into a problem or you want to avoid issues, kill the editor completely and rebuild inside of Visual Studio so the module itself rebuilds, and then go ahead and debug or reload the project afterwards.